All right, so this will be a quick video, basically, on, rotation, inertia, all that stuff. So this is like a little ramp here, and it is asking what is the height it was dropped at. So this is a hollow sphere, this ball right here. Its mass is 5 kilograms, its radius is 0.2 meters, and its velocity that it is going down the ramp is 5.64 meters per second. And we are given that the inertia is 2/3 mr squared for the hollow sphere. So now what can we do to solve for height? Well, we set up our equation with our KEs. So our equation that we need to know is KE total is equal to KE of translation, which is our linear kinetic energy, plus our KE rotational. So now we can expand these to what they actually are. So our KE translational is our 1/2 mv squared, right? 1/2 mv squared, plus our KE rotational, which is, we have to know, is 1/2 IW squared. So now we can plug in all of our numbers pretty much and, plug and chug. And our KE total, well, our starting energy, like what it has at the start, is our potential energy. What is potential energy? mgh. So now we can plug and chug. Now, potential energy, m, what is our m? 5.0, g, 9.81, height, that is our variable we're solving for, equals 1/2 5.0 mv squared, v is 5.64 squared, plus 1/2, okay, now here, our I. So what is I? I is equal, our inertia is equal to 2/3 mr squared. So 2/3, m is 5.0, r is given 0.20, square that. That is our I term, right? That is I. And then we have to finish with our, we have to finish with our W squared. Well, what is W? W is V over R, right? It's velocity over radius to find rotational velocity. So then we can just plug in V over R for W. So V, which is 5.64, over R, which is 0.20, and that is squared. Now we just numeric solve this out, and we can solve for our height, and it should come out to 2.7 meters, right? Now we want to know what the percentage of kinetic energy is translational and what percentage is rotational. So we can do this really easily by plugging back in the height to find the potential energy to start. 5.0 times 9.81 times 2.7, and this gives us 5.0, our total kinetic energy, times 9.81 times 2.7. This gives us 132.4 joules, right? And then to find the percentage, we can just plug in we can find out what 1/2 5.0, or 1/2 mv squared, 5.64 squared is, and then do this divided by the total to see the percentage. So times 5.64 squared, this comes out to 79.5. Then we do 79.5 over our total, 132.4, divided by 132.4, should get around 60%. So if this is 60%, what does it mean for our rotational? So this is our KE trans. That means our KE rotational, by default, obviously, 100 minus 60 is 40%. You don't have to do the calculation. And that is how to do a question like that.